So problem 2 on the homework. Okay, no one talk now. Okay, in the last unit you had problems. There was a problem on the test. We had to find the area of a region. You were able to use your calculator. It's now doing the exact same thing. You just can't use your calculator. Look at me. There is again, in my opinion, there's a plan A approach and there's a plan B approach to these problems. The plan A approach is the one I like. It's like practical. It doesn't require you going back and reviewing things you learned in previous classes, really. But I have to be honest, is it 100% perfect? No, there's a 1% chance we might make an error and have a problem, but I'd say 99% of the time we'll be fine. Plan B is you go back and you review everything you learned in previous classes, so when you read things like this, you know exactly what that looks like, and you still probably have about a 99% chance. There's still a 1% chance you'll make a mistake. I like Plan A because I don't really like going back and reviewing all this other material. I prefer to go forward. So I'm going to show you Plan A, but as I'm doing that, you want to kind of talk about Plan B, just to ask, and I'll show you. It says the area of the region bounded by the lines. This part's easy to remember. X equals 0 is a vertical line whose x-coordinate is always 0. So, draw a picture always helps. So let's see. Vertical line at x equals 0. X equals 2. You cannot use your calculator. Y equals 0, that's the x-axis. And this curve. Okay, we mentioned several times during the year that e raised to any exponent is always a positive value. So without going back and remembering exactly what this curve looks like, here's how I draw the curve. I know that every y-coordinate is positive, and it's some sort of curve, so good enough. That's my Plan A approach. Plan B would be to actually figure out what that curve looks like. I haven't found that necessary on the AP test. Honestly, just knowing that it's positive is good enough. Question? Cool. So I'm supposed to find this area. So just like the last unit, I'm really not finding the area of this shape. What I'm finding is the area of this rectangle. That rectangle being the blue line itself. So it's a very narrow rectangle. The y-coordinate at the top is found using this formula. The y-coordinate at the bottom is always 0. The width of the rectangle is dx. This is why I said to Ella, it's not a big stab, so it's a little stab.
Got it.
No need to quit. So.
I kind of want to quit, but I won't.
Question? Cool. Extra credit for the whole room. Raise your hand and tell me, what is this calculating right here? Feel free to talk. I gotta get more hands. What's that calculating? This is a good motion. I like that.
Yeah.
You relate to that?
I was just racing.
Ada, what is it?
Oh, the height.
The height. So, hey, this will calculate the length of that blue rectangle there. How many knew it? 0.2 for Ada. Hands up. What's the purpose of the x in the formula? Come on. Why is there an x? Talk if you need to. Want more hands? Here's a hint. I don't know if it helps. I'd also like to find the length of that red rectangle. I'd also like to find the length of this green rectangle. So what's the purpose of the x? Well, Mike.
Still, if I get the next value, you plug in the rest.
So the idea is that in this space, there's how many rectangles, Micah? There's an infinite number. I pick an x to identify which rectangle. So this is going to find the length of one rectangle at one x. How many knew it? 0.2 for Micah. So that's why we use an integral to go find the area of each and every rectangle. So my integral will look like this. E to the x over 2 dx, starting at an x-coordinate of 0, ending at an x-coordinate of 2. Question? I prefer multiplication to division. I find most people get stuck when it's division. You switch to multiplication, no one gets stuck. So this is the same as so to solve the integral, I have to use the fundamental theorem, which means I have to find the antiderivative of this. I just use the expanded exponential rule. Please, Jim.
Why did you keep the x?
Here. So x divided by 2 is exactly the same as 1/2 multiplied by x. 2 points. So I'm using the expanded rule. The a is 1/2, the b is 0. Wave at me if you want me to talk about why I know how to use that I need to use the expanded rule. So just plug it in now. So this becomes 1 over a e to the ax plus b. This is the antiderivative of this. And then I evaluate the antiderivative from 0 to 2. Questions? That is an accurate statement. It's very accurate. You never know what's going on in there. Dividing by 1/2 is the same as multiplying by 2.
Yesterday, and made them give Jared a slip to come to the but he to lure him out of class.
You don't want to talk about anything.
He sent someone else to get it. Just comes up.
Where does the 1/1/2 come from?
So look at your pink sheet. You're okay. Look at your pink sheet.
Oh, wait, yeah.
Good
Well,
now.
why is it? Oh, is it 1 over B? It should be 1. Yeah, you're right. Yeah.
You're good. Go out. Some solid backslacking there. Call it that neurosurgeon now to take care of Devin's back. Okay. Moving on.